So the next topic what we have here is priority, priority queue, or it is also called as heap data structure. See, already we discussed in detail about priority queue functionality, how the priority queue is going to work. Okay, based on priority, it is going to give the results. I already covered this with multiple cases, around some 10 to 15 cases we covered. But internally, what will happen in this priority queue, we need to understand. Sir, first of all, it is a binary tree. It is a binary tree. So binary tree means what? At most, how many children you need to maintain? Two children. But please make sure it is not a binary search tree. So it is a complete binary tree. It is a complete binary tree. Complete binary tree means what? Level by level, it is going to fill the data. Level by level. So means what? Sir, first node will be inserted here. Second node will be inserted here. Sir, third node, not here. It will fill that level. That complete level is going to be filled. After completing the level, then only the next insertion from left to right, like that, filling will be performed. It is a complete binary tree. Please make sure it is not a binary search tree. Why we are saying it is not binary search tree? Because the elements are not arranged in the less than, greater than, such type of possibilities are not possible. So what is mean by complete binary tree? I can add one point. All levels are all levels are completely filled. All levels are completely filled except last level, because last level we can't give guarantee. Okay. And what about the filling? Sir, filling should be done from left to right. So how we are going to fill the data? From left to right. So, and please make sure the heap order property. What is the heap order property? Very simple. The children values, whatever you are taking, the children values are always greater than or equal to the parent values. And the children values are always less than or equal to parent values. If parent is very less when compared with the child, it is called as min heap. So something, nothing but ascending order. Means what? Minimum value will be there on the root node. What about this one? This one is called as what? Max heap. So which is nothing but descending order. In this case, the maximum element will be there on the root. And please make sure, is there any such type of tree that we have seen? No, sir. So we can't represent heap tree, okay, in class list format. Sir, why? Because we can't format based on the minimum, based on the maximum, right? That's why here we are going to use the concept of arrays to store the data. Okay. And I told already. So how to insert a node at a position x? Already some formulas are given, right? Left side of x. Anyone remember the formula? What is the formula? In the tree diagram I explained. What is the formula? How to find out left side of any node x? 2x plus 1. How to find out right side? 2x plus 2. Based on these formulas only, we are going to arrange. Sir, what is mean by min heap? Which element should be there at the top? The root node must be smallest element. In the total tree, the smallest element you need to identify and you have to put it in the root. That is called as min heap. So max heap means what? Sir, the root node must be the maximum, or I can say largest value, like that we have. Are you clear with the structure? Please confirm. This is nothing but what is mean by priority queue. If you are clear with, so I will explain insertion and deletion operation on this priority queue. Any questions?
No, sir.
Right. Sir, can I go for a program? Please confirm.
Yes, sir.
Yes, sir.
Right. Now, so to implement this program, anyway, we are going to use arrays concept only. So I am taking a test class as usual, and I want to implement this manually, right? That's why in the test class, maybe if you want, we can import that util package also. So inside a test class, I am taking one static class called heap. In this only, I will perform all my operations. Then, so in the main method, we are going to create object for the heap. So heap obj is equal to new heap, and I will add some objects and I will print. Anyway, we can't print, right? So we can perform something like in our heap data structure, I mean priority queue I have shown. We are keep on performing delete operations. So now we are ready to implement this heap. And I said earlier, we have to use arrays concept because it is not implemented based on tree structure. So why we can't implement? For binary tree there is a rule. For binary search tree there is a rule. For AVL trees there is a rule. But we can't frame any rule for this heap. The only rule is the topmost element should be either minimum or maximum. What about remaining? So remaining can be in any order. So then how we can insert or delete? We can't do, right? That's why. Now, for this heap class, I am creating one array list. I am creating one array list which is capable of holding integers. So let us name it as ARR is equal to new array list. Just I am creating one array, beyond that nothing. Next, public void. I will implement one method called add. If you want to add any integer object, this add method is going to work. So if you want to remove any values, we need to implement remove method, like a public void remove method is there, which is going to remove one element. Which element it will remove? Root elements. Suppose after removing, so the height, the minimum element, suppose consider in the tree, I removed the root node. Then we need to find out the next minimum element in the total tree and you need to bring it as a root. For that, there is one special operation is there called heapify. Based on some index, you have to do this. That method also we will implement. And after that, so public int top element, we have to return always top element. How to return top element? Arr dot get of 0. And there is one more element is there, one more method is there called is empty. So what is is empty? We are going to return if arr dot size is equal to 0 means we have to return true, saying it is a empty. Otherwise it won't return. So skeleton wise, do you have any queries up to this? Just add method, remove method, heapify, peak and is empty. But I have written code for peak and is empty. We need to write for add, remove and then heapify. If you are clear, I will explain one by one. Any questions? Clear? Now, so the first one which I am going to add is, I will add 3. I am going to add 3. So what will happen? So we have to add that 3 in our tree. Okay. So this is nothing but array list, right? Index based array list. 0th location and first location and second location, like that it will be there. So assume I want to insert the data. Yes, data came. Array list is also there. Sir, can I add directly? No. Why? Because we have to perform something like heap operation. How to do that? That part only I am taking. The first step is we have to add the data at the end. How to add? arr dot, so there is one method is there called add. So that add method is going to add the given data at the end. What is this add method? Add method is present in array list class. So this element will be added. What is the element that we have given? 3. So if you want a tree diagram for this, just for visualization purpose, this is nothing but the data. Then, sir, up to this any queries? Please confirm.
No, sir.
Clear?
Yes.
Now, so what is my next operation? Assume I want to insert one more object. What is the object that I am inserting here is 4. 4. So where we have to add that 4? We need to add that 4 here, correct?
Yes.
But visually it will be added here. Am I right?
Yes.
Now we need to write some logic. What is that logic is among these two elements, which is the minimum we need to identify. Correct? Because minimum element should be there at top, right?
Yeah. Yes.
But is the 3 is minimum or 4 is minimum?
3.
That's why there is no problem. But of course we have to check that. So how to check that? I will write one logic. Please speak along with me. Integer child index. Child index means what? The index of 4, correct?
Yes.
How to get arr dot size minus 1? Because we inserted at the last, right?
Yes.
Now tell me, what is the child index value?
1.
Size is nothing but 2.
2. Yes.
2 minus 1 means 1.
1.
From this we have to find out parent index. How to find parent index? We have a formula, right? Integer parent index is equal to, so child index minus 1 by 2. What is a child index? 1. 1 minus 1, which is nothing but 0. 0 by 2 means 0. Its parent is nothing but 0. What is the use of these two formulas is, what is the latest node that you inserted, its index and its parent index we are checking, because we have to compare with its parent, right?
Yes.
Now what is the condition that you need to take? While loop I am writing. What is a while loop condition is, arr dot get of child index value is less than arr dot get of parent index value.
Sir, at line number 12, can't we do just ci minus 1 y by 2?
Ci?
Minus 1 will suffice, right? Why we are dividing by 2?
Because for every node 2 children will be there, right?
Okay. Okay.
Maybe for this example it is working. Suppose if the another node is there, then it won't work, right? It will give, suppose consider here one more node is there.
Okay.
If you take ci minus 1, what will be there? What is ci here? Newly inserted 2, right?
Yes.
2 minus 1 will become 1. Is it
One.
parent? No,
No.
this one is the parent, right?
Okay.
You understood, right?
Yes, yes.
Now observe. Sir, very important. arr dot get of ci. Ci index is 1. In first location, which element is 4? In parent index 3. Condition not satisfied. That means the element which you added is not lesser element. Then there is no problem, right?
Yes.
If there is any lesser element, then only problem will come. Up to this clear, Amma?
Yes, sir.
Now, so I will try to add one more element. What is the element that I am adding is 2.
Okay.
Now what will happen? First step, we have to add that 2 at the ending. This is common step, and here also visually it will be like this, correct?
Yes.
Now observe. After adding, what is the child index value that we added? Size is 3. 3 minus 1 means 2. What is its parent index? 2 minus 1. 1. 1 by 2 means 0.
0. Yes.
So get the element present at 0th location, sorry, second location 2. Is it less than? Get the element present at parent location 3. Condition true, right?
Yes.
Can I say these two elements we have to swap, correct?
Yes.
These two elements we have to interchange. Forget about the remaining. We are not required to care. Clear? How
Yes.
I am updating is, I will take one temporary variable In that, I'm going to store child index value. So what is the temporary variable content? Get the element present at that particular location 2. That means I removed this. Okay. Next, after this, what I am doing? ARR dot set of in child index ARR dot get of PI. What is a parent index? 0. In 0th location, which element is there? 3. That 3 I am going to update where? In child location. Got it?
Yes.
Next, ARR dot set of in parent index, which value we have to set? Tempa.
Yes.
Now what will happen? So already temp is there with us. Its value is nothing but 2.
Mm.
Now this parent and child got updated. Correct?
Yes.
Please observe clearly. This is child index. This is parent index. Correct?
Mm.
These values got changed or not?
Yes, it got swapped. Yeah.
Can I say again this value we have to compare with its parent? Of course, here it is not there, but generally we have to compare. Correct?
Yes. Yes.
So for that, what I will do is this one will become child index. This one will become parent index. Got
Parent.
it?
Mm. Yes.
What is the logic for that? Child index will become parent index. Parent index formula we have, right? Child index minus 1 by 2. This process will keep on repeating.
Mm. Okay.
Clear?
Yes.
Now I will take one more example. You will get clarity. Up to this clear, ma? Is the minimum element came to the first or not?
Yes, came.
That's all.
Mm.
Clear.
Yes.
So now what is the next thing that I'm going to do here is, let me add one more element. What is the element that I'm adding is 6. So 6 will be inserted here. Visually it will be inserted here. There is no problem, right?
Yes.
So now I want to insert 7. So it will be, or let me take any other element like 1.
Mm.
Where it will be inserted? Physically it will be inserted here.
Yes.
Now, but it is not the correct place, right?
Mm.
Adjustments will be happen. I will take in 2 colors. Listen carefully. First time, what is a child index? 1. Correct?
Yes.
This is the child index.
Mm.
Now, how to identify the parent index? Child index. Sir, child index is 4, right?
Index. Yes. Yes.
4.
Index is 4. Yeah.
4 minus 1 is 3. 3
4.
by 2 means 1. In first location, whatever element is there, it is the parent.
Okay.
Okay. Now
Mm.
observe, get the element present at child location 1. Is it less than the parent element? Yes, right.
Yes. Mm.
So we have a clear 3 lines of code is there, which is going to change the element present in this location to 1 and in this location to 4.
To 4. Yes.
That means here 1 came and here 4 will go. Correct?
Yes. Yes. Yes.
Can I say I moved the minimum element to the parent? But
Mm.
now we have to repeat this process. Child index is nothing but this one now.
Mm.
So that means your Ci will become what? 1.
1.
So who is Pi? We need to calculate this one. Pi
Mm.
formula is Ci minus 1. That means it will become 0. This is Pi.
Mm.
Because this element got updated, we need to compare with the 2 also.
Mm-hmm. Yes.
Since it is a loop, get the element present at child location. In first location, we have 1. Is it less than the element present at parent location? Yes.
Yes.
Then what we have to do? So here 1 will come, here 2 will come. So
Okay.
here 1, here 2. Can I say the minimum element is moved to the top?
Yes.
That's all.
Then
Forget
again
about the
they
remaining
CI.
elements.
Mm-hmm.
Remaining elements, it will be in any order, but I don't want.
Yeah.
So I am concentrating only on the top element. Got it?
Yeah. Yes.
So this is the way how insertion is going to be done in heap trees. Clear?
Yeah. Yes.
Is it possible to print this? Yes, we can print. But the problem here is you should not print. The reason is you will get clarity only on first node. Remaining nodes, it can be in any order, right? So in the priority queue, I already explained, we can't print the priority queue. So if you want to print, what you have to do? You have to remove the elements one by one.
Okay. And one more thing, sir. After this adjustment, again we'll update CI and PI, right? So there is no condition where we can break the loop after updating. So it will like go infinite
No,
loop.
no, madam.
No.
See, previously this one is PI, right?
Uh-huh.
What is PI value? 0. What is
Zero.
the CI value?
2, right? No. It's 2, huh? 2.
No, 1.
No, 1. Yeah.
Index.
Yes, yes, yes.
Hmm? Hmm. Now what is the next one? Next PI will become what?
PI will be 0
1.
minus
1.
1.
1. So your CI will become what? Oh, sorry, your CI will
So
become
CI
0.
will be 0 and PI will be
PI will
minus
be, so 0 minus 1.
1.
Minus 1.
0
Minus 1
minus 1
by
by
2
2.
means 0 only.
0. Yeah.
And now see, get the element present at first location, 0th location, 1. Get the element
Okay.
present at first
Okay.
location, false.
Acha. Got it.
Once if it comes to the root node, automatically it will break.
Mm-hmm.
Hmm?
Mm.
Hmm. Clear?
Yes.
Now, how to remove? Sir, very simple. If you want to remove any node, can I say where we need to remove? First node only, right?
Yeah. Yes.
What I will do is, for removing the first node, I will swap first and last elements. If I want to remove, I will swap first and last elements. Hmm. So if you swap first and last, can I say 4 will come here and 1 will go here?
Mm.
Correct?
Yes.
So here 4 will come, here 1 will go. Sir, why you are moving to the last? So first let me move. How to move? Integer
Cycling.
data is equal to arr dot get of 0. In 0th location, which element is there? And integer temp is equal to, okay, let me take one temporary variable. It is also same. Better I will add this one for our convenient purpose. So now temp is equal to arr of get of 0. Same instruction, but why I stored that data is at last we have to return that for that purpose. So we calculated the index value 0, which element is there, that I copied to temp. Previously it is 1, right? Now how to set? Arr dot set of, in 0th location, arr dot get of arr dot size minus 1. Which element is there at the last location? Can you please update that? Last location is 4, that I moved here.
Yes.
After this, what we need to do? Arr dot set of, in arr dot size of minus 1, in last location, can you please update temp? This one I have done. So
Yes.
why I moved last? Because removing the element at last, no need to do any operation, right?
Mm.
If you remove anywhere, remaining elements we need to swap or you need to adjust.
Mm.
But if you move to the last, what will happen? We can remove last elements. How to remove? arr dot remove. arr dot remove of. So arr dot size minus 1. Can I say after this remove method, this one will be permanently removed? Correct?
Yeah. Yes.
Now there is no problem. But after this, we have to check the minimum element and we have to move to the beginning. For that, you need to do heapify. Clear?
Yeah.
With
Yes.
respect to which node you are doing, sir, I don't want for any node. I will total restructure the tree. Clear? So what is that heapify? It is taking one index value. It is going to restructure. We have to restructure this tree, right? Compulsory.
Yeah.
So how to restructure? For that, try to find out left value, left subtree value based on the index whatever you have given. So try to find out right subtree value based on the index whatever you have given. Tell me, what is the left value? So index value with respect to 0, index is 0. For 0th index, left index is 1, right index is 2. Correct?
Yes.
Clear?
Mm.
Now after this, we have to compare integer. So mi is equal to index. I am taking some temporary variable. What is the mi value now? 0.
0.
Now what we are going to do is, if left is less than arr dot size and arr dot get of mi is greater than arr dot get of left. If this condition is satisfied, minimum index is equal to right. So if right is less than arr dot size and arr dot get of minimum index is greater than arr of get of right. So I am trying to identify the minimum element index value. Observe carefully. Is left is less than size of the array? Yes. Right is less than size of the array? Yes. Now arr dot get of minimum index. I am considering minimum index is 0. In 0th location, which element is there? 4. Is greater than. Is greater than. So arr dot get of left element 4. Condition not satisfied. Correct? Sorry, left is 1, right? In first location, which element is there? 2.
2.
Condition satisfied or not?
Yes.
Yes. That means what? We are comparing this element with this element. Got it?
Yes.
At the same time, we have to compare this element with this element also, right?
Yeah. Yes.
Now, when I am comparing 4 and 2, so this condition satisfied. That's why minimum index value is left. That means the element which is present at first location is the minimum element.
Yeah.
Now I will compare these two. Is updating or not? We have to check. So right value is less than 4. Okay. AR dot get of minimum. Minimum value is nothing but what?
2.
2, right?
Mm.
Is it greater than rightmost? Condition not
False.
satisfied. That means among these three, that is what? Parent node, left child, right child, the minimum index we captured. We are not updating the value now. We captured the minimum index, correct?
Yes.
Now what we have to do? We have to update this with parent, correct?
Yes.
How to update? If index value is not equal to minimum. Sir, I calculated root node. Index is nothing but what? 0, right? Minimum index is nothing but what? 1. Suppose if the element present at the root, for example, consider -4, then what is the minimum index? 0 only, right?
Yes.
If index is 0, minimum index is also 0, no need to swap, correct?
Correct. Yes.
Then what we have to do? Otherwise, integer as usual, temp is equal to arr dot get of the element present at index. That means what? The element present at index, which is nothing but what? 4, right?
Yes.
So we are remove sorry. So we are removing this 4 and we will take in some temporary place. Then what we have to do after this? So arr dot set of in index, I am going to set arr dot get of mi. In minimum index, which element is there? 2.
2.
I am setting that one here. And
Yes.
here we have to move temp.
Temp. Yeah.
So that means what? Here 2 came, here 4 came. Correct?
Yes.
So one more instruction, arr dot set of mi comma index. Correct, Amma?
Yeah. Yes.
Now what we have to do? We completed this process. Now we need to check which element we updated. This one, right? Minimum index.
So line number 47, mi, comma, temp will be there, right?
Mhm.
We are
Line number
setting
40.
7. We are setting temp, right?
Mi comma temp. Sorry.
Yes. Yeah.
Now after doing this, We interchanged these two, correct?
Hmm.
Now we have to compare this element with its children, am I right?
Yeah. Yes.
So because this element may be minimum element will be present here, right?
Mm-hmm.
Correct?
No, I
Suppose
didn't.
here assume instead of 6 I have 1. We
Okay.
verified this part only.
Mm-hmm.
We need to verify this part also, right?
Yes.
So for that, what I am doing, heapify of
Am I?
mi.
Hmm.
It is a repetitive process.
Yes. Yes.
Clear?
Yeah, got it.
That's all. This is called as priority queue what we have.
Mm.
Now, sir, is it possible to display that priority queue? No, we can't perform display operation until the value of this priority queue is not equal to empty. So what we will do, system dot out dot println of that priority queue dot peak element I will display. After displaying, I will try to remove that element. Okay. Now see what will happen. Unexpected return value. So heapify, and what is another line? Line number 32. Here better to use integer because return type is data, right? That's why. 1, 2, 3, 4, 6. In which order we have given? In the same order is it there? No.
Yes.
Now I am giving 5. Now I am giving 9. Now I am giving 8. Now I am giving 7. In any order you can give. But the first element will be always minimum element.
Minimum. Yes.
Got it?
Yeah.
So this is for minimum priority queue, minimum heap. So if I want to do for maximum heap, what modification we need to do in the program? Tell me. What we need to do? While inserting, if it is greater, we have to insert. Correct?
Yeah. Yes.
That is one change. After removing, what we need to do? While heapifying, if any element came lesser than. Correct?
Yes.
Now observe. Clear?
Mm.
So this is the way how you are going to heapify this. Any queries?
No, sir.
Sir, everyone please respond. Clear?
Yes. Clear, sir.
Right. If you are clear with this, there is one more sorting is there. I will explain that and I will close. Clear up to this?
Yes, sir.
Based on this, there is one sorting technique is there. What is that sorting technique? Heap sort. Heap sort. So what is mean by heap sort? Arranging the elements in ascending order only, base or descending order, based on which data structure? Please confirm. Heap. Already we covered, right?
Yes.
So in the main program, what I am doing here is integer array I am creating with the elements 1, 2, 4, 5 and then 3. So what I will do, system dot out dot println before sorting, what are all the values that we have in this. Now after sorting, which sort I am doing here? Heap sort ascending order I am calling. So we have to implement which method? So heap sort method we have to take. Public static void heap sort in ascending order, which will take one integer array. Heap sort internally work based on heap data structure only. So what I am going to do is we have to restructure the tree. Okay, we have to restructure the tree. So for that there are two things are there. First is We are arranging ascending order or descending order? Please confirm.
Ascending.
Ascending order means last element must be which element? Ascending order means we are constructing minimum heap or maximum heap? Maximum heap, right? Correct term. Okay, we will see whether it is ascending or descending. So first we have to build. First step is we have to build a heap. Then what is the second step? So we are going to push the maximum element to end. These are the two steps I will do. Observe carefully. So n is equal to a dot length. That means what? Array length I am going to find out. So for consideration purpose, we have an array with how many elements? 5 elements. Let us assume this is nothing but array what we have. So 0th location, first location, second, third, fourth. So the elements already there, 1, 2, 4, 5, and then 3. So first we calculated the length. Length is nothing but what? 5. After calculating the length, what I am doing is, for integer I is equal to n by 2, I greater than or equal to 0, I minus minus, I am doing one operation which is nothing but, so heapify. So heapify of that array, that I comma n. So because the tree structure is what? This is nothing but the node 1, and this is nothing but the node 2, and this is nothing but the node 4, and this is nothing but the node 5, and this is nothing but node 3. Correct, sir? Please confirm.
Yeah, yes.
Now I am doing that heapify. What is that heapify? In the heapify, I will do some modifications. So what is that modification is? Observe carefully. Public static void heapify function I am taking, which is going to take one integer array and which will take some index value and integer length of the array. So the process, you know, what is the process? We have to find out left index. How to find out? 2 into index plus 1. And we need to find out right index. What is the formula?
2
2
into
into
index
index
plus 2.
plus 2. After this, we need to find out which index? Maximum index. What is the maximum index value initially? Index only. Now observe, I am marking in different color. So what is index value initially?
0.
Not 0. Here see, first time your I value is n by 2. What is n value? 5. 5 by 2 means what? 2.
2. Yes.
First time index is nothing but what? 2.
2.
Then what is its left side? So 0, 1, 2. What is its left index? 2 into 2, 4. 4 plus 1, 5. Correct?
Yes.
What about right value? 6. Now maximum index is nothing but a 2. Now
Okay.
we are finding maximum element among these subtree, right? What is the condition? Is the value of left is less than n, and a of the element present at that location, is it greater than a of max index? If it is true, max index will become left. Otherwise, right value is less than n, and a of right value is greater than a of max index, then max index will become what? Right. Tell me, left value, is it less than n? No, right? Right value, is it less than n? No. That means this case is fail because there is no children. Correct?
Yes.
Now what is the next step that we have to do? For I is equal to 2, we completed this method. For I is equal to 1, we have to take now. Correct? So for I is equal to 1, what will be left? So 2 into 1, 2 plus 1, 3, third index. And right will become what? 4, fourth index. Among these three, we are calculating which value? Maximum value. Clear?
Yeah, yes.
Now how to calculate? Is left is less than 5? Yes. Then maximum index is equal to, already we consider maximum index as a 1. Now check a of element present at left, that means a of 3, 5. Is it greater than? So a of 1, yes sir. Then minimum maximum index will become what? Left, which is nothing but 3. Third index is the maximum value. Then so right value a of right, that is nothing but 3. Is it greater than 5? No sir. That means maximum element present at which location? Third location. Can I say now you have to shuffle these two? Correct? Correct, madam? How to shuffle? If max index is not equal to the index, how to shuffle? Integer temp is equal to a of I. So a of I is equal to a of max index. A of max index will become what? Temp. Then again we have to call heapify on the array A, on the index 0, and then index. Like this I am passing. What is the meaning of this? Sir, just we interchanged these 2 and then 5. That means the maximum element we moved. Clear up to this, ma? If you are clear, I will move further. Clear? So what is the next step here is, sir, we calculated the maximum element in one level. What about next level? We have to call that heapify by passing the array. So what about your new index value? Your new index is nothing but what? With respect to 0. Now again for 0 it is calculating. So from the total tree it is going to do this process. Can I say maximum element is nothing but what? 5. So here 5 will come, here 1 will come. So this is nothing but heap structure what we have. Clear up to this? Sir, we calculated the maximum element. We push it to the top. Clear, guys? Please confirm. Now after this I am pushing that maximum element to the ending. How to push? For integer I is equal to n minus 1, I greater than 0, I minus minus. We are running a loop from the reverse. So what we will do? Temp is equal to a of 0, first element. Then a of 0 is equal to a of I. So a of I is equal to temp. Okay. So then one second. Yeah. So then again we are going to do same heapify for which element? For which element? 0 comma 1, 0 comma I. So with the modified array again I am going to do. So after calculating the maximum element from the tree, we are moving that maximum element to the ending. So that means 5 will come here. So 3 is going to come here. Now we will perform the same operation for this. What is the maximum element? 4. 4 will come here, 2 will come here. We will perform heap operation on this. Like that, it is a recursive process. So this class heap is not required because I implemented that algorithm in the heap sort itself. That's all. It is for ascending order. Let me check is the code is working. Line number 24 and 26 here. Just we need to take these brackets dismissed. Undefined symbol I in line number 29 and 30. Here we have to take index, not I. So all the elements are sorted in ascending order. This is heap sort ascending order. If you want to do heap sort descending order, what you need to do, those modifications you need to do. What is that modification? Sir, here in heap sort descending order, what is a modification that we need to do? The first modification is we have to move the smallest element, minimum element to the ending. So rest of the things are same. How to move? E of 0 is equal to E of I is equal to temp, like that. And in heapify, what we are going to do? Whenever lesser element came, we have to identify. That's all. Beyond that, nothing. Let me run. Sorry. We have to call in descending order. So is the descending order came? Yes. So based on that heapify, we are going to sort. Here, what is the input? Heap tree we are taking. Everyone clear up to this? Please confirm. Understood, guys? Right.